All right. Anyone here used the wheelbarrow before? It's a pretty ingenious device used for transporting heavy objects. So you have, here you go. Here's a wheelbarrow I drew for you. So here you have the tire, you have your bucket, you have whatever you put in your bucket, and you have the handle that you lift up on. And that's just a leg to keep from falling over. All right? Now, the way this works, right, is you have a long lever arm here that you can apply force to lift or move a load. Okay, now where you put this load in relation to the fulcrum and the lever dictates how much force you have to apply. So if I have a 100-pound rock and I put it in the back of the wheelbarrow here, then it will be more difficult to lift. You see there's a shorter lever arm between the load and me, and the load is further from the fulcrum here. If I move this load forward to near the fulcrum and I lengthen this lever arm, then I reduce the amount of force you have to apply on this dramatically, as I show here. All right. So you have a longer lever arm, which is further from the fulcrum. I apply the force really far from the fulcrum. The fulcrum is just the pivot point. And here's my load really close to the tire. So as I lift up on this, the load that I feel, or the force it takes to pick this up, is very low. If I move this to the back, then the force will go up, but it's still less than it would be here because I have this longer lever arm. Now if we take this wheelbarrow and you tip it on end, like this, then it's going to look a lot like the shift mechanism in a Subaru. And here it is. Just like the wheelbarrow there, we got the fulcrum, we have a load, and we have the force applied to the lever arm. See that there? You can see the relationship, how that's the same. I don't know if this is the right direction or not, but it's the same idea. I hope you didn't get too dizzy there. With the fulcrum, load, force. Same thing happens here. Fulcrum, load, force. Now, the load hasn't changed any. It still takes the same amount of, it still has the same amount of friction. It still has the same amount of force needed to actually move the gear selector itself inside the transmission. But what has changed the distance from the fulcrum and the distance from the lever arm that you use. So in a short shifter, there's a couple different ways you can do it. You can shorten the lever arm, and therefore the distance traveled is lower. If you were to draw that, let me get a little angle on here. If I'm going to show you, let's see where we're at. Back it up a little bit. Okay, so we'll say it has to travel this many degrees, okay, to engage a forward gear, and you shorten the lever arm to this length here, then this distance you will see is less than this distance here. And therefore you have shortened the throw of your short shifter. Now by itself, that can have a significant effect in the distance traveled. But what does that do? That imparts more force on your hand. It makes it more difficult to push this load in the transmission, because now this lever, between the lever arm, between the load and your hand, now the distance has gotten shorter. So you feel more of the force, right? You have torque multiplication here and here, only with a shorter lever arm you have less torque multiplication. This hasn't changed. This is still the same amount of force needed to engage a gear. Just what you perceive and what you feel has changed. This is still traveling the same distance as it has always traveled to engage the gear. Now what you can do also, in addition to shortening the arm to give it a shorter throw, is you can move this up and down in relation to the fulcrum. To make a shorter throw shifter, you move this away from the fulcrum even more, which has the same effect. You see right here in the old position, right? It traveled this far. And then if you were to move it up for it to travel the same distance now, I'll put that there. That means the lever only has to tilt to that angle. All right. So now you'll see that instead of traveling this whole distance up here, we've shortened the arm and reduced the throw. We've gone now to this new distance. The load is still the same. The force you feel in your hand has again gone up even more, because just like moving the rock in the wheelbarrow to the back from the front increases the load that you feel on your hand and how much force you have to push due to the lack of torque multiplication, happens the same thing here. This moves up. You feel more force, you have to push harder. And that's one reason you get that positive feel with a short shifter. And so in the end, we have this guy. Nope, wrong one. This one here. So we have a shorter arm and a longer distance to the fulcrum here. So this would be your short throw shifter. We reduce this length usually by a lot, like an inch or inch and a half, based on what brand it is. And you've lifted this up, usually about a half inch or so, maybe a little more. There's only so much room in the tunnel, or where the gear shifter is fed up through the body. The sheet metal of the body only has so much room. Anyway, so you do that. You save the combination of forces here, of effects here. You've reduced your torque multiplication in two ways: shorter lever and further distance from the fulcrum on the load. But the force isn't changed. So no, short throw shifters do not give you more leverage. They do not increase the amount of force felt on the gears, on the gear selectors, the shift forks, or anything else. In fact, it takes more force to move that by your hand, to move them and engage. So if you happen to bend one with a short throw shifter, you're only doing it because you're driving like a meathead.